Hi, everyone. I'm Sandy Chaika from Riverside Brookfield High School just outside Chicago, Illinois, and I'm here to talk to you about lists. In this video, we're going to use pseudocode from the reference sheet to determine lines of code necessary to complete an algorithm. So what will we learn? For list operations, to be able to write expressions that use indexing and list procedures. For algorithms involving elements of a list, write iteration statements to traverse a list. It'll be helpful to know the exam reference sheet provides basic operations on lists. List procedures are implemented in accordance with the syntax rules of the language. Traversing a list can complete a traversal where all elements are accessed, or partial traversal where we only look at a portion of the elements. Iteration statements can be used to traverse a list, and there is pseudocode for loops on the exam reference sheet. Knowledge of existing algorithms can use iteration in constructing new algorithms. For lists, some common algorithms that are useful are finding a minimum or maximum or sum or average of a list of numbers. We can also use linear or sequential algorithms to check each element of a list in order until the desired value is found or all elements have been checked. So looking at our reference sheet, we can see how to index a list. A list bracket I in the square brackets or in a rectangle if we're in the block is getting the element at index I of a list. And this next area here, a list at I is taking the element at index I and storing it in X. We're doing the opposite here. We're taking the value that's in the variable X and storing it in a list at index I. In this scenario, I'm taking an element from the list at index j and storing that value also into the element at index I. Insert allows us to put a value in a list at index I. Append allows us to add a value to the end of a list. And remove will allow us to take the element at index I and delete it from the list. The length of a list is returning how many elements are currently in the list. And here we have a loop specific for lists that allows us to access each item in the list. So we're going to look at some practice questions here. People were surveyed whether they preferred cats or dogs, and preferences were stored in a list called animals. The preferences are strings. Cat represents the preference for cats and dog for the preference of dogs. The following code segment is intended to traverse the list and display the number of people who prefer cats and the number who prefer dogs. So here is our code. I want to know which of the following should replace missing code number 1 line and missing code number 2 line so this code will work as intended. There are 2 answers here. So pause your video, take a look and see if you can figure out which 2 will work. Okay, I hope you took some time to look at this. So when I look at this, let's take a look at A. These are both, we can see, going to be selection statements. I am only going to add to my number of cats if they had a preference for cats, and only to dogs if they had a preference for dogs. So I need some kind of selection statement, some type of if statement. In A, it checks if animals equals cats. Well, that's a problem because animals is the list. I don't want to know if the whole list is equal to cats. I want to know if one specific element is equal to cats. For each response in elements, response is the variable holding each individual element. So A will not work, but B is checking if the response is cats. And if it is, cats is updated. Else, since dogs was their only other option, dogs will be updated. So B does work. When I look at C, if animals equals cats and if animals equals dogs, again, I have a problem here. I cannot use the list. I don't want to check the entire list to cats or the entire list to dogs. I need to check each element. which is stored in response. I can do these as separate ifs. There's no problem with that. So C does not work, but D does. All right, let's look at another example. Names of students who signed up for a club are stored in a list called new members. The code segment is intended to look for a member with a given name stored in a variable called key name. It is meant to output the index of the position of the student with key name, and if the name is not in the list, -1 should be displayed. So I have the code, and again, I'm looking for what should go in missing code here. So pause your video, take a moment, and see if you can figure this one out. I hope you looked. So let's take a look here. I am actually going to need to access every element of a list here. So I'm going to need some type of loop. All of these are doing loops. Notice I set index of name equal to -1. Index of name is going to store where the key name is. Right now, I don't know if it's there, so I'm leaving it at -1. I equals 1 will let us check the first element of our list. And N is going to keep track of how many members are in our group, the length. So for each I in new members, well, if I is meant to be an element of new members, that doesn't make sense. I can't do new members of an element, so A does not work. For each index of name in new members, well, index of name is actually supposed to be an integer. That's not going to work. I can't put that in here. Repeat n times. So this will repeat the number of elements times. So however many elements I have, however many members I have, it will go through each time. I will start at 1. If it finds key name, it'll update my index. Either way, I'm going to look at the next index. So index I will be updated each time, and I will check from 1 through n. That's exactly what's going to work. When I'm done, I will display the index. If it found it, it would have been updated to I. If it never found key name, I will still be -1, which is what we wanted it to update to. So what should we take away? For list operations, we want you to be able to write expressions that use list indexing and procedures. And for algorithms involving elements of a list, be able to write iteration statements to traverse a list. The reference sheet provides operations on lists, and procedures are implemented for lists in accordance with the syntax rules of the programming language that you learn. Traversing a list can be a complete traversal or just partial, and iteration statements can be used to traverse the list. It helps if you know some knowledge of algorithms that can be used for lists. Common ones are finding minimums or maximums, sums or averages, and we also can be used linear or sequential search to check each element in a list for a desired value. Don't forget to become very familiar with this reference sheet. It is going to be very useful on the AP exam in May. Thank you for watching this video. I hope you'll come back and watch some more videos in the CS Principles library. Until then, go out and have some fun with CS.